This is the circuit assembly video for the Newmarket High School ICS3U Arduino unit. Class, you have a kit that has several components in it. You have a breadboard with an Arduino attached. Now, you may have an Arduino Nano that looks like this, or you may have one that looks like that, or you may have an Arduino Uno. They will all work with this wiring diagram. The only difference is that if you've got an Arduino Uno, it will not be on the breadboard. Your wires will have to just run off the breadboard to connect to the Arduino Uno later. But we're going to wire up for this Arduino Nano. So this Arduino microcontroller is attached to a breadboard. And the basic way the breadboard works is this. We have what's called a ravine running down the center of the breadboard. Anything on this side of the breadboard is electrically isolated from anything on this side of the ravine. So if you've got a component on this side, if you run it across the ravine, it will connect across the ravine. But if it's just over here, there will be no electrical current going from this side to here. If you need electrical current to run across the ravine, you can run a jumper wire from here to here. But right now, we're not going to need that. If you have a breadboard that's got this black line drawn on it, that means that this breadboard is such that this part of this current, these voltage supply rails are isolated from this side, and the same thing down here. So if that's the case, you just want to put a small piece of wire from red side over the line to the red side and green side over the line to the green side. And then eventually, if you need more components and you need to use this side of the board, you would do the same thing. You'd put a wire from here to here on the red and from here to here on the blue for ground. Now, you are definitely going to start off with doing this. You are going to run one wire from the ground pin to the blue rail and one wire from the 5 voltage supply pin to the red rail. Now, on these nanos, the 5 volt pin has no sticker on it, no label on it, but if you count 1, 2, 3, 4 from the right, that is the 5 volt rail. It's the same as on this one, and if you look, you can see that it says, the 4th pin says 5V, which means 5 volts, okay? So you'll run one wire from the 5 volt pin to the red rail. So these rails here are what we use to supply voltage and ground to all our components in our circuit. Okay, so you've got a supply of voltage to the red rail and a supply of ground source to the blue rail. Now we're going to start assembling our components. So you have 4 push buttons. You've got some little red wires to connect different components to the voltage side. You have 2 LEDs. You have 2 470 ohm resistors, and you can tell they're 470 ohm because when you look at the stripes, and it might be hard to see, but the stripes are gold, purple, blue, and yellow. Those are used just to limit the amount of current flowing through the LED so that we don't shorten the life of the LED. We don't need to have full brightness. An LED typically requires 3 volts, but we're supplying it with 5 volts, so that would be really bright, much brighter than we need, so we just use the resistor to reduce the current and voltage going to that LED. So you've got 2 LEDs, 2 470 ohm resistors. You have what's called a light-dependent resistor. Looks like that. Excuse me. And we have a 1 kilo ohm resistor. And the colors for that are gold, red, black, and brown. And then we have 4 10K ohm resistors. And the colors for those are brown, black, orange, and gold. And those are what we use for our pull-down resistors on our buttons. We bring the buttons down to ground to 0 voltage at all times unless they are being pressed. The pull-down resistors make it so that the Arduino doesn't detect a button is being pressed when it's not being pressed. Because the nature of an Arduino is that the pins, the voltage on the pins, are constantly floating between 0 and 5 volts. So if you don't have a pull-down resistor on them, you can't be guaranteed that when the button is not pressed, that the Arduino is not seeing 0 volts. So we use these pull-down resistors to make sure that the voltage stays at 0 until we press the button. And then we've got some wires here to connect our components. So the first thing I would recommend you do is start installing your components on the board before we do the wiring. So I'm going to start with the light dependent resistor, and I'm going to install it about 10 pins in from the right side of the board like that. Then I'm going to take the 1K ohm resistor, going to bend it like that, bend the legs like that, and then one side of the resistor is going to go on the right side of the LDR, and the other side will go to the ground. So it looks kind of like that. So from the right side of the resistor to ground. Now I'm going to take one of these little wires, and I'm going to go from the left side of the resistor to the 5-volt supply, the red rail. So it looks like that. Now I'm going to install all my buttons. Excuse me. So if we look at a button, you'll see there are 4 little wires coming out, 4 little legs coming out. These legs go on either side of the ravine. So I'll install one like this. So you see that I've installed it so 2 of the pins go into the board, and it goes across the ravine to the other side. So I'm just going to do that for the other 4 buttons, the other 3 buttons. And I'm just leaving a row or 2 between each button just to space them out a bit. We got lots of room on this board, so we don't need to have things packed tightly together. So you should see them all nicely sitting down inside the board like that. Okay. Now I'm going to run a red wire, one of these little red wires, from the right side of each button to the 5-volt rail. Now this guy's just a little loose, so we just press it down like that. So I'm going to take this little red wire, and I'm going to go from the right side to the red rail. So right side to red rail. So now you can see the right pin. I missed that one. Let's just get that guy in line there. So the right pin from each button goes to the red 5-volt rail. Now I'm going to take my orange and black and gold and brown 10K resistors, and I'm going to go from the left pin to ground. So I'm going to go from the left pin of a button to the ground rail. So it looks like that. So I'll do that for each button. Now I'm leaving a bit of room between the button and the resistor because there's going to be a wire. Well, actually, I'm going to use the wires on this side, so it doesn't matter. As long as the resistor goes from ground to the left pin in each case, you're good to go. Now I'm going to do my LEDs. LEDs are polarized components, which means that the current has to flow in the right direction through the LED. The longer of the 2 wires, the wires are called legs. The longer of the 2 wires is the positive or anode side, and the shorter one is the cathode side, the negative side. So the positive will go towards where you're getting your voltage from, and the negative side will go towards ground. So I'm going to make it so that the long side is on the right of our circuit. So I'm going to put them like this, and then I'll do the blue one. So I'm going to put the blue one, the long side is on the right again. All right, so I'll move them down a bit so we've got some room. So you can see That's what my LEDs look like at the moment. Now I'm going to put in my 470 ohm resistors and they're going to go from the negative side, the cathode side of the LED, which in this case is the left, they're going to go to ground. Now you may have slightly different valued resistors in your kit, but basically you don't want to use the 1K. Those are for the LDR and it's too much resistance and you wouldn't see much light coming out of the LED. And a 10K resistor, the orange ones, you wouldn't see any light at all. They're too big. There's too much resistance. There's not enough current flowing through it. So I'm going to take my 470 ohm resistor and I'm going to go from the left side to ground, and the other one left side. Actually, I'll move this a bit. There we go. Okay, so you can now see that the resistors, the 470 ohm resistors, go to the left side of the LEDs. I'll move this back up so it's in line with the other one just to make it a little neater. Actually, let's leave one pin on top because we're going to run our supply lines to the Arduino now. Okay, so now we're going to start wiring up to the actual Arduino. First thing we'll do is the LDR. We're going to go from the negative side, the same side that this resistor's on, to pin A0 on the Arduino. Now on this model of Nano, there is no A0 written on it. The A0 is immediately to the left of A1. If I look on this kind of Arduino, you can see that it says A0 right there. But it's the same relative place. So I'm going to take this long wire here, and I'm going to go from the negative side of the LDR to pin A0 over here. So A0 and the negative side of the light dependent resistor. Now I'm going to wire up my LEDs. So I'm going to take one of these purple wires here. It doesn't matter what color you use. Just find a wire length that reaches from the pin you need to your component. So I'm going to wire the blue LED up to pin 11. So from pin 11 to the right side of the LED. So you see how that purple wire is lined up with the right side of the LED. And then I'll do the same thing for pin 10 to the right side of the red LED. So you can see it's lined up on the red side. And now we're going to do the buttons. So for each of the buttons, we're going to go from pins 6, 5, 4, and 3 to buttons 1, 2, 3, and 4 to the left side of the buttons. So this is button, when you're looking at your circuit with the Arduino on the leftmost button is button 1, and then button 2, button 3, and button 4. So we're going to go from pin 6 to button 1, pin 5 to button 2, pin 4 to button 3, and pin 3 to button 4. So I'll take one of my wires. I will go from pin 6 to the left side of the button. Now, you could either I'm putting it up here just because it's cleaner and out of the way, but if you wanted to, you could always put it on the same side as the resistor on the bottom side too, because this button spans the ravine. When that button's pressed, the connection would be made. So what happens is we get a voltage here and we get our ground here. So when the button is not pressed, the Arduino input pin, which is this, is reading 0 volts through that button. And when we make the connection, 5 volts from the 5 volt rail will run through this side to this side and then to the pin on the Arduino, and that pin will recognize that button is pressed down. So now I'm going to go from pin 5 to the left side of the button 2, pin 4 to the left side of button 3, and then pin 3 to the left side of button 4. So you see that all the yellow wires go from the left side of the button to the input pins, to their respective input pins on the Arduino. A0 goes down to the negative side of the light-dependent resistor. We've got the right side of each button goes to the 5 volt through those little red wires. The left side of each button goes to ground through the 10K resistors. We have the cathode, the shorter side of each LED goes to ground through the 470 ohm resistors, and the positive anode side, which is the longer wire side of each LED, goes to their respective pins 10 and 11 on the Arduino. Now I have a sketch already loaded on this Arduino just to test the circuit, so I will plug it in. Now, before I plug it in, you are not going to connect your Arduino to your computer before you've given it to your teacher for him or her to inspect it to make sure it's wired correctly. If it's wired incorrectly, it can damage or cook the Arduino. One quick way to cook the Arduino is to have both the 5 volt and the ground going to the same color rail on the rails of the breadboard. That is short-circuiting 5 volts to ground on the Arduino. This will very quickly heat up, and it will fry the Arduino. One way you know that you may have done that is as soon as you power it on, one of the LEDs may be dimming, maybe glowing quite dimly. If you see that, you immediately unplug the Arduino and check your wiring, and then have your teacher check it. So you definitely don't want to in any way have some way for current to go from negative to positive along these rails. And as you get used to designing circuits, that'll make sense. But for now, please just have your teacher confirm that everything's okay. So I've confirmed this is okay. I'm going to plug it in, and we'll test out the Arduino with this test sketch that I have. Got the chime that we've got an LED. So now I'm going to try each button. So I'm going to press button 1. So it turns on my blue button. Button 2 turns on the red one. Button 3 makes the blue one flash. And button 4, if I hold it up here closer, it makes the red one cycle fade in and out. And then I have some code in my little test sketch that lets me see if the light dependent resistor is running. And as I cover it, I see different numbers in my serial monitor indicating that the amount of light hitting that resistor is changing as I cover it. So this circuit is now ready to go for your Arduino unit, and just have your teacher check it out, and then you can plug it in, and we will start working through the different activities so you can learn how to use all these different components, and eventually you'll build them together into something of a functional product. Thank you very much.